So the first quadrilateral we're going to talk about is a parallelogram. And a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So what we're going to do is we're going to go to a program called GeoGebra, and we are going to construct a parallelogram, measure a bunch of things in it, and then talk about whether sides are congruent, what angles are congruent, what angles are supplementary, and so on. So let's get to it. So to construct a parallelogram, the first thing we're going to do is construct a pair of sides, adjacent sides I should say. Then we are going to construct parallel lines to the opposite side. So I want to be parallel to that side through that point, and I want to be parallel to that side through that point. And now I'm going to make the last vertex here and go from there. So basically I went and hid the two extended lines so that we can finish it up here and make it nicer to look at. So once I have this created, now what I'm going to do is measure the sides. And if you look here, I'm just going to click on each side. And what do we notice here, right? When I measure the sides, okay, what do I notice about the measures of the sides? You should notice that the opposite sides end up being congruent. So when we go here and we measure the sides, were the opposite sides congruent? Yes, they were. Were the opposite angles congruent? Well, what we got to do is go back and measure these angles. So we're going to go ahead and measure these angles. And right away when we look, okay, if I move these to see it a little better, this angle is 53.5, 53.5, 126.5. Can we go ahead and say that these opposite angles are congruent? And the answer to that is yes. Okay. Now, were the adjacent angles congruent or supplementary? When I look at this, will these adjacent angles, say A and B, will they be congruent? No. But will they add up to 180? Yes. So what we say is that the adjacent angles are supplementary. Okay. And were the adjacent sides congruent? And you can see that the answer to that was no. Okay. So now what it wants us to do is construct the two diagonals. Okay. So I'm going to go here. I'm actually going to pull these measures out so it's cleaner to look at inside. And I'm going to construct one diagonal here. And I'm going to construct the other diagonal here. Then I'm going to go ahead and measure this diagonal. That diagonal is 8.3. That diagonal is 4.6. And let me move these measures to make it a little clearer. Right? This diagonal was 4.6. This one was 8.3. Are the diagonals here congruent? Right? They are not. Okay, these are not congruent. But now what we're going to do is I'm going to actually hide this object. Oh. Actually, I'm going to just do that. Now what I'm going to do is plot a point at the intersection here. Now what I'm going to do is measure the length of each half of the diagonal, meaning A to E has a measure of 4.1, E to C has a measure of 4.1, B to E is 2.3, D to E is 2.3. So when I look here, although the diagonals weren't congruent, if I look at the intersection point, that intersection point ends up being the midpoint of diagonal AC, and E ends up being the midpoint of BD. Therefore, what we say here is the diagonals here, the diagonals bisect each other because, right, that intersection is the midpoint. Okay, so now next, they want us to measure the angle at the middle to determine, are these diagonals going to be perpendicular to each other? So if I measure this angle here, I get 123.5 degrees, right? Can we say that the diagonals are perpendicular to each other? All right, and the answer to that is no. Okay, then we want to determine if the diagonals bisect both pairs of opposite angles. So when I go here, I'm just going to measure like these two angles here. So if I measure angle BAE, oh, I got to go to the measuring tool. BAE, I get 33.9. And if I go DAE, I get 19.6. Okay, and right away here, if I look at that measure and this measure, does this diagonal cut that full angle in half? No. If it doesn't work for this angle, it won't work for any of these angles right now. So when we go back here, we're going to say no to this. Okay. Now, what we're going to do here is come up with three theorems. And we are basically going to say theorem one is the fact that opposite angles are congruent in a parallelogram. Then we're going to say opposite angles, excuse me, we'll say opposite angles are congruent, but this one will be opposite sides are congruent. And the final one is the fact that the diagonals bisect each other. And you have to know that this means they cut each other in two equal halves. So these properties will now be used to answer problems, okay? So let's look at the first one. If we had to find the measure of angle S, T, and W, well, if we know that opposite angles are congruent, if angle R is 112, I know that angle T is 112. But what's another property? Well, if these lines are parallel, we said adjacent angles are supplementary, right? So we can find angle S by doing 180 minus 112, which is 68 degrees. Now, if angle S is 68 degrees, what's angle W going to be? Since they're opposite angles, 68 degrees. All right. Number two, here we're using the definition, or basically the property, that in a parallelogram, we know opposite sides are congruent. So right away, I know QR is congruent to PS. Therefore, 3x minus 15 is equal to 2x plus 3. When I go ahead and solve, I get x equals 18. Now they want us to find QR and PS. Well, I know QR is equal to PS, which all I have to do is plug 18 in for x. 2 times 18 is 36 plus 3, which would give me 39 units long. And that would be the measure of both segments. Okay, using the property again that opposite angles are congruent. In order to find angle E, G, F, and H, I have to find Y so I can find these angle measures. So what am I going to do first here? Find the value of Y by saying angle E is congruent to angle G. So 6Y plus 4 is equal to 3Y plus 37. So subtract 3y equals, subtract 4, 33. So y is equal to 11. So when I plug that back in, 66 plus 4 would tell me that this angle is 70. So angle E is 70. So right away, what's angle G going to be? That's going to be 70. And now to find angle F, I'm just going to do 180 minus 70 because remember, these adjacent angles are supplementary. So that's 110, which means angle H right away is 110 degrees. Okay. So number 4, right away, I know a property of a parallelogram is diagonals bisect each other. So right away, I know these segments are congruent, these segments are congruent. So to find x, I'm going to say 2x minus 5 equals x plus 7. So we get x is equal to 12. To find y, 6y plus 1 equals 4y plus 9. Subtract 4y, I get 2y. Subtract 1, I get 8. Y is equal to 4. And this is using a property that the diagonals of a parallelogram bisect each other. And the last one, right? So when I look at this and I set up the fact that these are congruent, y is equal to x plus 1. And once I set these equal to each other, I know 2x equals 3y minus 7. Both of these equations give me, right, two different variables. So what I'm going to use is substitution to find the value of the first variable. Everywhere I see a y over here, I'm going to replace it with x plus 1. So 2x equals 3 times x plus 1 minus 7. So 2x equals 3x plus 3 minus 7. When I subtract 3x, I get negative x equals 3 minus 7 is negative 4. So x is equal to positive 4. Now to find y, I'm going to go ahead and plug that in. 4 plus 1 is 5. So now to find AE, AE, to be honest, if these are congruent, plug an x in, 2 times 4, this is going to be 8, which means this is 8. Then 4 plus 1 is 5, which means this is 5. And that would be the length of each of those segments. Go ahead and try the homework and let me know if you have any questions.